Cool. All right, so let's move on quickly to our speaker. So today we're going to hear from Liz Varga. She's a professor in complex system in the Civil Environmental Geomatics Engineering Department at the University College London, where she leads the Infrastructure System Institute. She has a very long CV, and she's very amazing. I just had the opportunity to hear her presenting this morning, so that was pretty good. She was awarded the Commander of British Empire in the King's Birthday's honor for service to critical infrastructure, among so many other things. But I think the important thing today is to hear about her research and what also hear about back from us questions. Yeah, open to the discussion, I think. If you have any questions online, please pop them in the chat or in the Q&A session, and we are going to go to them after the presentation. Over to you, Liz.
Yes, sure. How will we? Perfect. Thank you very much. Okay, so good evening, everyone. Pleasure to be here. I hope you enjoyed the talk. Please save your questions. I think we have some coordination at the end. But if you're happy with what I'm saying, I quite like nods in the audience to know that you're in agreement as well. Then I think you're still engaged. Okay, so have I got a clicker? No. It's just the mouse. Okay, that's fine. Can I take it like this and maybe? Maybe it doesn't. Okay.
Now try it again.
Okay. No, go back. Yeah, please. Yeah. Okay. So, So I'm talking today about the intersection of risk, reliability, and resilience. So I'm trying to keep my agenda very simple. I'm going to talk about infrastructure first, so that we're all on the same page about the context of talking about these risk, reliability, resilience. And then I'm going to talk through each one of these three phenomena, and then I'm going to come to some proposal at the end and see what you think. Have I made the right conclusions? Do you think we can extend the suggestions I'm making? So it should be quite simple, straightforward agenda. But there's quite a lot to get through. So no doubt, I mean, I'll get an indication of when to stop, but I'm watching the clock for 6:45. Okay. Okay, good. Okay, so first of all, infrastructure then. So infrastructure is this system of people, resources, materials, assets, flows, kit, technology. It's a connected system. It's not just one organization's assets. It's that integrated whole set of things that have to be connected in a way that deliver the services that we want from it. So we class it as a special form of asset, like a set of assets, because it provides these essential services. So these essential services are generally provided through what we class as different siloed systems. So you might think of an electricity system, or you might think of a road network or a railway system. All of these are infrastructure systems, but it's actually the end-to-end system that we're interested in, because it's the whole set of systems that provide us with the essential services. So when, for example, you're using a transport system, you need power on that transport system. There'll be resources that are needed for that transport system that are not totally contained within the operator of that transport system. So if the power fails, or if the telecommunications fails, or the data center fails, it means that the transport system will fail, and it's outside the control of that organization. So it's important that infrastructure is understood as being beyond the control of the organization or an organization. Okay, and because infrastructure is so important, we say that society depends on it. It provides those the ability for society to flourish, even society to succeed and be viable, because without infrastructure, it might not be able to do that. So it's a critical class of assets and systems that deliver these needs. Okay. So another way of thinking about infrastructure is that they provide lifelines. So if you don't have potable water, or if you, even today, if you don't have a mobile service, you cannot make a call, people immediately start panicking. It becomes something that causes them anxiety, can cause them stress. very, very quickly. So how can we prevent those outages happening in our infrastructure systems to sustain those lifelines? And I mean, there's a whole variety of analyses done. So I've just picked this one that sort of gives you an example of the sorts of things that you need infrastructure to be able to do in the event of an interruption. So for the economic output, you might need the ability to substitute and conserve needed inputs. So if you have an economic system that has a supply chain, it has a flow of materials, there might be alternative routes that need to be supplied for those materials in order for your essential services to continue to be delivered, because what you don't want is an interruption to those essential services. Another example here is about the time to restore the lifeline services. Now, so this is particularly a social aspect. People have an expectation that their services are not interrupted for time, that they actually do have the service recovered in a reasonable amount of time, so that they can carry on either with their work or with their social life or whatever activity they're doing. So there's a societal expectation for infrastructure services to be continuous and available. Okay, and we could argue that the right to these essential services is a human right, maybe embodied in the Sustainable Development Goals, when we have, although they're obviously targeted towards new developments, actually these goals are like beacons that we use for anything that we do in social systems. So the fact that we need to have, be able to have healthy lives, be able to promote well-being, have access to clean water, all of these speak to lifeline services. These SDGs are sort of giving us an indication of what ought to be available all the time. So when we have an interruption to essential services, it becomes a real problem really quickly, because we're already not meeting the expectations that society has bought into through these goals. And of course, it increases the quality of life. So the access that you have through being able to get maybe travel through a metro system to get a job, which you previously couldn't get access to because the mobility system wasn't good enough. Those things actually enable us to improve, like socially improve, because we can get better jobs, we can have access to different services in different places, things that we either enjoy or we want to sort of make money from. So it's an opportunity when we have essential services to actually go beyond what we have available in our own locations. So we're not constrained. So that's not just transport, it's also telecommunications, giving us that access to information, to knowledge about things going on beyond our local community. So actually, it's infrastructure becomes a very fundamental enabler to what we can do as society and how we can develop as society. And obviously vital to improving quality of life and integrating vibrant places, because actually the more we see infrastructure developed into urban environments, the more it attracts people in, because they can see that there are more opportunities, more things to do, things that they might want to do that are just not available unless they come to these urban areas. And another really important aspect of infrastructure is that they belong to a special class of goods. So not just the assets, but all the systems that are part of infrastructure. So they belong to this sort of quadrant where we're not excludable and we're non-rivalrous. So to be non-excludable means that everyone has the right to have that access to that service. So, for example, if we have limited supplies of some services, and so once we've exhausted that supply, it becomes excludable. But things like fresh air, access to a national defence force, everyone should have the right to it. It can't be limited or constrained. Not only that, they're non-rivalrous, which means that there can't be competition between different suppliers. Like, you should be able to access the same level of service across all supplies. So there's no competition there, and it has to be inclusive. This is obviously, that's the ambition for public services. We obviously see this isn't really the reality of it, because often some public services can be more expensive for some people. We see this particularly in rural environments where it actually costs more to be living in these rural places. The ambition is for it to be this non-rivalrous, non-competitive, but it isn't always the reality. So there's definitely it's like a protected class of assets that are recognised by the utility companies and by the governments, the public sector, and they have to be treated differently. So we can't treat them like a private good. So this is still all part of infrastructure. I'm almost getting to the last two slides on infrastructure, then we can go on to the 3 Rs. So in the globally in the 1980s, there was a wholesale privatization. Obviously not every country, but many of the westernized countries sold off national assets. I'm sure there's a legacy here in New Zealand where this happened. We had a massive selling off in the UK under Margaret Thatcher when she was Prime Minister in the 80s. Same in Ronald Reagan in the US was doing the same thing then. And all our public assets became privatized. And we had what we call PPPs, public-private partnerships, wherever we wanted to build new infrastructure. Everything was done with the private sector, working with the public sector. Now, what it meant was that the public sector gave up the control for those assets and often lost staff to the private sector companies. So it was like a brain drain to the private sector, away from the public sector, which was seen as a market efficiency and appeared to be working. We've still got those systems as they are, but we've got lots of evidence that actually these systems don't work very well. We have mountains of regulation that has to be facilitated by the public sector to check that the private sector is at least providing the minimum outcomes they should be from these services that have been privatized. So there's an element of control and regulation that still happens by the public sector. And the whole argument was about doing regulatory reform to try and minimize the amount of regulation. But actually, if anything, it's made the regulation even more complicated. So the ambition was nice, but it didn't quite deliver. That's not to say there aren't success stories. I'm sure there's lots of private success stories as well. I don't mean to be sort of completely negative about privatization. Okay, now the other thing to think about in infrastructure is that what we're seeing is that it's not, and I said this at the start, it's not just the physical assets, it's also the systems that we have. That includes the processes, the people systems that deliver these infrastructures, but also the digital layer that we're increasingly seeing upon the physical layer. So we're seeing sensors, we're seeing monitoring, we're seeing lots of models and data sets being collected about flows of water or power or whatever it might be, just so that we can capture what's going on in these systems so that we can get either early warning or better understanding. We can make plans, we can test scenarios. So we're collecting lots and lots of data. I mean, we've heard of smart cities, of digital twins. All these phenomena are growing in the infrastructure world. Not all sectors are growing at the same rate. So we see digital particularly strong in aerospace. But I mean, if you think about national air traffic control systems, I mean, they've been digitalized for decades. Same with the electricity industry. They've had a SCADA network where they've had data flowing around the network for a very, very long time. But other sectors, maybe like water, are a bit slower. Transport has been ramping up a lot, particularly with the advent of electric cars and autonomous vehicles, because they actually now need the information so that they can actually enable that sort of development on the roads. So we're seeing a mixed bag of digital not evenly spread across all sectors, but and also digital not always delivering anything to do with risk or resilience or reliability. They're often doing it because of productivity. It's just about, can we cut some staff? We can make something mechanical, automate it with the digital solutions. So it's been very, very targeted at efficiency improvements. But it hopefully is changing, because we've now done probably as much efficiency as we can. Let's try and do other outcomes that we need from the future. So basically, if you think about infrastructure, you can sort of think of it as three layers of systems: the physical systems, the digital systems, and then the people systems. And the people systems are the processes, the staff, the organizations, the governance. So it's an integrated cyber, physical, digital system. And of course, those maybe these could have been done with different colors. These could be from different sectors. So you could have energy, you could have water, you could have sewage, and all sorts. So they're all across sectors integrated. Okay, so summary of infrastructure, and I've only spent 10 minutes, so we've got plenty of time for the rest. So we've got, so infrastructure is currently organised into very disciplinary silos. So we see water companies, we see water utilities, electricity companies, so on, transport networks, and it is a consequence of the privatisation that we've had, that organisations tend to specialise in their areas. It's not saying this is wrong, this is just how we see it. We don't see companies working like multi-utility companies. It was a phenomenon that we described about 20 years ago, but never really emerged. We also see that there is a mix of private, largely private and mostly public regulated companies, but not all countries are the same. Of course, there's a lot of publicly owned national assets in lots of countries, that therefore the whole system works very differently in terms of what can be done in these organisations and these utility companies. And we're seeing the increase of digital platforms that are actually holding the data, which is causing a bit of a phenomena actually in the infrastructure world, because actually the companies that have the data are often the ones that are able to support the decision making. And often it's big IT companies that are coming in, sorting out the data system, the digital platforms for the utility companies. And the utility companies then almost become subservient to the knowledge that's in the digital platform. So they become operators rather than decision makers. So it becomes, it's sort of changing somewhat to be much more dominated by the digital platform providers. Okay, so some questions. Actually meet society's needs, particularly as we see changing demand from societies. We see changing hazards, changing impacts on people of different social groups and vulnerabilities. Is infrastructure sustainable as it is now? Because obviously there's also the whole financing being cut down, less money on maintenance and repair, refurbishment, and which communities will suffer, because it's usually the same ones that suffer time and again. So it tends to be, again, very discriminatory in terms of the decision making. And does more investment need to go into this to actually start meeting the human needs? But where would that investment come from? And where's the political driver for making those investments? So that's it on infrastructure. Okay, still with me? Good. Okay, so let's have a look at the next subject. So I'm going to talk about reliability, and probably this is, if any engineers in the room? Engineers? Yes, you're going to love this bit because you're going to know about this totally, okay? Right, so we can talk about two types of reliability. Component reliability, yeah, good. Okay, so what we do when we design a new engineering system, we look at the components, we work out how reliable they need to be under different conditions, under different tolerances, whether it's pressure, temperature, whatever stress with load we want to try and put on it. We work out what the maintenance regime will be for those assets, like how frequently do we want to service them so that they maintain their performance levels. And we also have to test them under expected operational conditions. But sometimes the scenario testing can be under unexpected ones. So we can maybe stretch our testing to go beyond where we expect the component to have to work, because we know obviously that the world is not always like it's been in the past. It's a changing world, multi-hazards and so on. But essentially we have a set of conditions that we have to meet when we do the component reliability testing. And if you can imagine, we've got a bridge, we've got a number of members, and we can look at those components in isolation, and we can say, well, does each component member of that bridge meet the requirements of the testing? And we can do that assessment, we can tick it off, yes, it does, and therefore we're happy. Now, of course, we can check whether our component, having built the bridge, we can check, is it working right? So we can do that by inspection, and this was the old way. Nowadays we might send a drone, or we might put sensors on the bridge and actually be getting readings about the condition of it. We can analyze the data we collect to make to get insight. Is it still performing the way we're expecting it to be performing? And we can do all sorts of work on that to say, well, actually, when do we expect it to fail? Do we need to send out maintenance crew in the next 6 months, or can we avoid it? Does it look like it's performing beyond our expectations? So it depends on the load, depends on the weather and everything else. So we've got really thorough component reliability, I would say, in organizations. Now, when we worry about the whole system, the component reliability isn't enough. We need to think about the joined up components of the system, and we call that systemic reliability or system reliability. And we can analyze the system in a multiple numbers of ways. So one of the ways we can do that is by creating a network model of all the components. So if you imagine the bridge, we now have all 25 members in our model rather than just individual ones. Now we can look at those components either in series, and we put them into series to say, well, if any one of these in the series fails, the bridge is going to fall down. So if like any one fails, will cause a disaster. We can look at which components can work in parallel. So if any one of those components is working, then the bridge will stay up. So actually you've got different series of sets you can look at for the component parts. Or you can do what they call minimal cut sets, which are basically, it's a combination of series and parallels, because what you do, you take a set of components, in the minimal cut set, they operate in parallel. So if any one of them is working, everything is working. But if you join up the minimal cut sets in the series, if any one of those minimal cut sets fails, the whole bridge fails. So we've got plenty of network models that can do these analysis really effectively. So there's like, we've got it buttoned down. Not only that, if you don't like network modeling, you can use fault trees, you can look at Markov chain or Markov modeling. I mean, there's plenty of methods, really good, sound mathematical methods that can be used. Actually, we can share the slides because probably you can't tell from the DOIs exactly where the papers are, but all these are, like, you can look at the papers and you get lots more information. So system reliability is great. Okay. Now, so what's good about reliability then? So when we measure reliability, we can say, well, actually, it's reliable if it doesn't fail, because we've obviously planned for it not to fail, both as a component and as a system. But failures will occur because actually we have conditions that we didn't expect. We maybe didn't do the maintenance we planned. The load might be different from what we expected, and so on and so on. So what we do, we measure the interruptions. We can measure how often they occur, we can measure how long they were for, and we can measure the intensity, like severity of the interruption. And that tends to be like your measure for how well your systems are. And it's very widely understood in industry. From the electric power industry that I probably know really well, they've got 3 different measures that they use for that. They've got the system average interruption frequency, SAFER, then SADA, and then CADA. So they've got different measures for interruption, and there's formulas that they use. Everyone can compare across organizations. So if you're a power company in one place, you can compare it with another company's experience, because these are standard methods. So when the system is designed, so you've got the components, you've got the systems, you've got all the testing you're doing. When you do the testing, the system has got to be strengthened before you actually build the system, so that it does meet any of the normal operational conditions that you're going to expect for the system to be operating in. And the testing is done by setting out criteria for that testing. It's looking at things like the conditions that the system will be operating under. So you make assumptions about, like, the temperature will only ever be 35 degrees centigrade. We'll only have this many people using the system. All those assumptions go into the models. And if the system is working, then there's no work to be done. If anything fails on these anticipated operating conditions, then the system has to be strengthened even further before you're allowed to build it. So everything is done correctly before the creation of the system. Now, what they also test are what they call extreme contingencies, things that maybe are what we might call, or what we might have called a few years ago, 1 in 100-year events. And I say that only because 1 in 100-year events seem to occur every 5 years. Not that I'm cynical, but what you would have done is tested extreme contingencies, so things that you might not have expected. Now, what the guidance is in certain electrical power systems is that you have to do some mitigating events. So try to put some things in place that will stop things going wrong when those extreme contingencies do occur. So you have to make some efforts to do this, but they're not imposed, they're not mandated. And what they say is that's only even true for the critical extreme contingencies. For the things that we might never imagine, or that might be this 1 in 100-year event, you don't have to do anything. So there's some risk attached to people still using the system, because if those conditions do arise, then the system it could fail, and we don't know in what ways it will fail. So it's largely it's working. And largely, we don't have the extreme contingencies. But what we're seeing is that actually with multiple hazards, extreme temperatures, largely related to climate change, but a whole host of other hazards, we're seeing that these problems are occurring much more. And we're actually demand our systems to have more reliability than they have in the past. So if we do an overview of reliability, it's built into the design and into the configuration. We should be operationally monitored. So the people that actually run these systems ought to be collecting data, or at least doing inspections and actually understanding the condition of those systems. And there might even be, if we have digital systems in there, there might be automated alerts to say, actually, there's something failing here. Someone needs to come out and check it. So we do have those built into the system. So that's all good stuff. But we might be asking questions about, can we actually predict the system health of this system under the new conditions that we're experiencing? So if we're having the temperature rise, or we're having increased wind speeds, is the system still going to be working under those future conditions? And are the essential, like, if you like, the legislative and built like codes that we have to operate under, are they enough to make sure that these systems don't fail? Because we're seeing with the multi-hazards that actually there is pushing the systems to their limits. So that's reliability. So I hope that was all comfort zone stuff, more or less. Yeah, okay, good. Okay, so risk. Okay, so you've probably seen this sort of drawing before, where risk is at the intersection of hazard, vulnerability, and exposure. Of course, the hazards can be not just natural hazards, you know, with here in New Zealand, of course, you have a host of natural hazards. I'm very familiar with them, I'm sure, but they can also be I mean, I shouldn't really use the word man-made. I'm sorry about that. If you like, people created, like it could be a cyber attack, it could be a physical attack on some asset, but it needn't be a natural hazard or a hazard that occurs in the natural environment. Obviously, the vulnerabilities in our infrastructure are exposed by these hazards, because that's where things go wrong first. And then there's a resulting exposure, which is the extent of the damage that is now the risk that has to be assessed. Okay, so I've got an example here of the sorts of risks that we have in the UK on our National Risk Register. Let me just find something that's on. So we've got accidents and system failures. They are one of our top 9 national risks. Cyber is a risk. And of course, cyber, like I said, is increasingly another layer within our infrastructure system. So we see the risk appearing twice in our National Risk Register. So not only that, we have global risks. So the World Economic Forum in Davos, they revise their assessment of the global risks every year. So this is the 2025 version. And I'm quite careful to put what the percentage means. So we've got this figure of 23% for state-armed conflict. So this means that the 23% of the respondents to the survey click this as the top risk. And that was the biggest cohort of any risk category. So 14% of the respondents, so under 1 in 6, thought that weather-related was the biggest risk, extreme weather, yeah. So we have an analysis. I mean, they do this every year, so obviously they have a lot of people responding to these. So overall, it should be a reasonable understanding of what the risk landscape looks like. But of course, how we interpret this for local risks to our infrastructure is much more tricky. It just means that, yeah, there might be a state-based armed conflict, but what does that mean? Do we have to get the military out to protect our infrastructure? And how soon would we do that in different places? So it becomes difficult to apply. So anyone, a risk manager, really works on risk and knows risk really well? No one's admitting to it. Maybe. Okay, you can be the one to argue this one then, right? Okay, so risk is defined as the effect of uncertainty on objectives. So this is like if a risk might be something that happens or doesn't happen. There's a probability always attached to a risk occurring, and it's uncertain because there's this probability. So we don't know if it's going to come about or not. So when something does come about, when we have a landslide, when we have temperatures like 42 degrees as they had in Melbourne, that's no longer a risk. That's an issue because you've got to deal with it. So risk management sort of tries to predict when that sort of thing will happen and tries to recommend what to mitigate to stop it like having a big effect, but it doesn't deal with the actual consequences of the risk. Maybe the risk managers will then get the data about what's actually happened and they might refresh their models if their risk prediction was inaccurate. But actually risk is about the anticipation of something maybe going wrong. So it's about uncertainty, okay? This is from the ISO 31000, so anyone that does risk management will know this number off by heart. Yeah, maybe. Okay, so there are a whole host of risk management strategies, and you can find them in other ISO works. I mean, I can pick on one like emergency management. So there's already an ISO standard that tells you what to do for these types of activities. And obviously, emergency management doesn't kick in unless the risk of a disruption has occurred. But you manage that risk of a disruption and things may be going badly wrong by having an emergency plan, by putting in place the things that have to be done when the thing does go wrong. So there's a whole system of processes ready for that. The risk management also thinks about high impact events. These are sometimes called low probability, but as I said, I'm a bit skeptical about the 1 in 100. So it's not necessarily, it might not be low impact, low probability anymore. It will definitely be high impact. And the Sendai framework talks about 7 targets for these multi-hazard risks, because actually the biggest challenge will be that multiple risks happen at the same time and we won't be able to cope with them. So one risk has happened and very soon after something else might happen, and because your vulnerability has already been exposed, the chances of the next hazard coming along and actually making a massive impact on your system is much greater, because your system is already vulnerable. It's not operating to the way it should be. So it's a real challenge to deal with these multiple risks. Not only that, we've got a whole host of challenges for all of our operational systems, because we're reaching planetary boundaries. If things go wrong, we're going to be using the same supply chains to try and get the same source materials. People will be, for example, eager to get food chains supplying food in their areas, whereas there's disaster in a seaport, then everyone will have to suffer, because actually you've got a single point of failure. So there's a masses of compounding risks and that are creating wicked problems. Okay, so let's look at systemic risks then. So just like we looked at component reliability and we had systemic reliability, we've got risk, normal risk management or traditional risk management. We're seeing the emergence of a field called systemic or system risks. And the definition I found here is that systemic means the extent to which that risk is embedded in other risks. So you have links across systems. And as I described infrastructure, that's exactly the nature of infrastructure. We have things that are connected across systems, and therefore the risks are going to be greater. So actually any risk in an infrastructure system will be a systemic risk. So, and we can see that we're creating more and more of these systemic risks by the ways that we're choosing to organise, the way that we are attracted to come into urban areas, into cities, because that's where we can get the services that we are looking for. Just the changing demographics, the changing needs of populations are compounding the loads on our system, the demand on our systems. Another definition of what we mean by a systemic risk is a phenomena exceedingly complex and interdependent. And this is exactly what we mean by system. They're connected in myriads of ways, and we don't know exactly where those pathways will fail because of the multiplicity of the connections. Okay, an example from climate risk. So this is very much a wicked problem. It's a systemic risk. We are contributing to climate change, but also having to deal with climate change. So how are we changing our systems so that we make the climate index less, but meanwhile, we're still operating on our old systems, which are making it worse. So it's almost like we're fighting against ourselves. It's a huge systemic problem. And we have several climate models. these socioeconomic pathways in the Climate Change Committee, the IPCC, Intergovernmental Panel on Climate Change. I mean, they've set out these scenarios that we can use for testing potential climate futures and see how well our systems can meet those climate impacts. And then just to think about systemic risk governance, because we don't have the methods to deal with the governance of these systems when they are system risks, because they deal with risks that are pan-organisation. We don't have the governance groups or the fora to actually manage those systemic risks. Not only that, what we're finding is that because organisations can't do that, they can't go beyond their organisation boundaries, what they're doing is treating the systemic risks as if they were organisation risks and tangible. And just some examples that I found for you, and let me just find just one. So there might be, as a systemic risk, we might think of cyber attacks, but actually in an organisation, they might just treat it as a theft of their own information. But actually it's a widespread problem where everyone else is experiencing the same type of theft. And therefore, the actual consequences might go well beyond the own organisation. Okay, so in terms of overview of risk, obviously, everywhere's risk is different because risk occurs depending on your local hazards and threats and so on. The management of risk tends to be organisation-centric because organisations or institutions, whatever you want to call them, they have the power to act and they don't tend to go beyond their boundaries, or they're reluctant to go beyond their boundaries, certainly in infrastructure. And there's multiple levels of risk. And by what I mean is that there are some simple risks that you can deal with in the component level, and you can actually deal with risks at a systemic level through senior management and through governance at the organisation level. But some of the questions about risk management are the ways that we do risk assessment sufficient to actually represent these systemic risks accurately? Are the frequencies of risk assessment and escalation pathways adequate? So what we're seeing is that the risk assessment is done periodically. Sometimes every senior management meeting, they refresh the risks, but actually the risks are changing minute by minute, and it might be necessary to monitor some risks in a way that is much more dynamic. And then maybe how should risks be governed? Do we need some multi-agency governance? And what does the government do in that sort of role? And resilience. Okay, so I've got 5 minutes to talk about this, so I'll do my best. Okay, so people talk about resilience in different ways, and I think that's one of the difficulties with resilience is like, what do we actually mean? So some people talk about the properties that you have, like if you're redundant, you've got resilience, because if there's redundancy, it means that things can operate because when one thing fails, the other one kicks in. So they sometimes talk about capabilities. Have you got the capability to absorb? Well, okay, but what does that mean? Does that mean like how much capability do I need to absorb? So if I have a sea wall, I know that's got a certain height, but then if the wave strength is going to knock that sea wall down, the height of it is not going to make any difference. So it's not necessarily a capability that will work in all contexts. And people talk about processes. And this is really the sort of where we've latched on. It seems to be the most useful aspect of resilience, to actually think about the processes you have to do. And in fact, so from the ISO standard 22300, we've got this definition for resilience, meaning to absorb and adapt. So if you can take on board the hazards that come your way, and you can then adapt and respond to those in some way that mean that you can still offer your essential services, then you are resilient. Okay, and there are underneath the absorb and adapt, you might want to prepare, you might want to be able to recover. These are all part of the whole system, but absorb and adapt seems to be the minimal way of, it's like the most parsimonious way of defining resilience. Not only that, of course, even when you've had an interruption, the rest of your system still needs to operate. So you've got a tension in your organisation about where do you put your resources? Do you put them on the operational part that's still working, or do you divert them to the bit that needs to be fixed? So there's a tension even within resilience. And this is how we tend to measure resilience after the event. So all my functions were working all fine up until then. I had an interruption, things dropped out, and this is sort of indicative of the cascading failure. One system fails, eventually the other one fails, then the other one, until eventually nothing else fails. You got to the bottom level, and then you stop it failing anymore, and then you can start recovering those systems. So this is the typical curve. It's like volume over time. We can measure that space over the whole period. We can measure the, well, not with this, but we can measure the severity, like which ones of our services were critical. So we might only put the critical services in here and measure that, or we could put all our services. So there's different ways of measuring, but basically it's either volume or time, or a combination of volume over time. But it's retrospective. We can't know this beforehand. We won't know which ones will fail definitely under different scenarios. So we can't use that as a prediction for resilience. So some work that I've been doing with United Nations Office for Disaster Risk Reduction is in 2022, we're setting out some principles for infrastructure resilience. Now, these documents are available online. That was 2022. The handbook was published in 2023. It contains stakeholder guidance for how to implement the principles. And it's got some key performance indicators, so you can actually measure how resilient you are based on adopting the processes that we've put into these guides. They're underpinned because obviously United Nations were the customer, the client. They're underpinned by their Sustainable Development Goals and the Sendai framework. So they're embedded within these principles. So they're already accounting for sustainability. Actually, I don't need to use this one. This is just a reminder that we're really interdependent. Last November, we had the ISO 22372 approved, and this was taking forward the United Nations principles, developing them into an ISO standard. We kept the same 6 principles that we had in the United Nations work, but we've added some processes, if you like. So there were 33 in United Nations work. We've now got 44. So we've got more examples of things that you need to do to be resilient. Also in the standard, we talk about what sort of outcomes you might have from adopting these principles, things like reducing the severity of impact, the frequency of impact, and having sort of long-term outcomes by being able to, things like getting foreign direct investment. So as a country, if your infrastructure can be shown not to be disrupted very often, actually people will come here and have their businesses here, invest here, because it means that you demonstrate a level of uninterrupted essential services that is desired by people that want to invest. But also, obviously, it increases the quality of life because we're not in services. We're not causing health impacts, which are causing hospitals to be strained and other cascade effects from from the interruption of essential services. I don't think I've got time to go through these, so I won't give you the examples, I'll just tell you what they are. So we have 6 principles. So we've got clearly defined accountabilities and shared responsibilities. So this is about governance. You've got to find a way to govern beyond the organisation. It's about collaborating across for the purposes of providing essential services. Proactively protected is the next principle. This means that you've got to be prepared. So your component liabilities need to be higher. Your system reliabilities need to be higher. All the things that you can do by working actively with nature-based solutions, these things will actually mean that you have a more resilient infrastructure. Environmentally integrated. Make sure that the natural environment isn't going to harm your infrastructure and you aren't damaging the natural environment through pollution, because actually you need to work with the natural environment. It provides the resources that we need to provide infrastructure. Socially engaged. We need to be able to explain to the customers that we have, whether they're businesses or homeowners, that there are times when there will be disruptions and what they need to do if there is a disruption, what they should expect, actually engage with them, and even to the extent of getting them to reduce or avoid their discretionary demand, because that will help us repair more quickly because the demand will go down. We'll be able to divert the supply to where it's really needed. This is called adaptively transforming, but what it means is that for management to have flexibility to go beyond the organisation boundaries and to work together and collaborate. So that means building those relationships. And then, of course, continually learning. So we need to be collecting the data, analysing the data and monitoring in a much more dynamic way, because otherwise we don't know how resilient we are. It's a changing situation all the time. Okay, so those are the 6 principles. I'm afraid I haven't got time to do that. All my examples of flood. You can have the slides and please read them if you're interested. And I'll just mention this one quickly. It's in the European Union, they've already understood this need for governance across all of the 33 or 28 or however many countries there are in the European Union. So what they have is every single nation must identify those organisations that provide essential services, and those organisations have to report on what they're doing about resilience. So I know it's only a first step and it's only reporting, but what it would start doing is setting benchmarks for what people are doing in different countries that they're able to compare against and actually demand a minimum level of essential services. So do have a look at this. We call it SEER, Critical Entities Resilience Directive. Okay, so what we can say for resilience, we need governance, which we don't have at the moment across the multi-agencies in the context of infrastructure. We've got the principles which let us do the design, operate and learn, but then we're still confounded by the past experience of trying to do resilience, including our limited focus on recovery in the past, where we haven't thought about adapting so proactively. Our strategies have been very limited to things like creating redundancy, maybe past confusion that's created through the definitions that we've had. And maybe when we've also measured, we've conflated reliability with resilience. So we haven't thought about them as two separate things, because reliability is definitely different from resilience. Okay, last slide, but I need you to think about this one, because this is probably the one where I need the most input. So I've got simple X and Y axis. My Y axis is about governance. And as I've been mentioning already, we can think about governance in different layers. So at the bottom layer, I've got the operational, like continuity. So if you think about operations managers, so you've got a water treatment plant, you've got a railway station, you've got the operators of those systems. There will be things that those operators manage at that operational level and managing the potential disruptions. At the strategic level, you'll have the senior management team dealing with some of the risks, working out what's best for the organisation to survive and be viable and to develop over the short to medium to long term. Then we're having the multi-agency one, and probably that's focused on harm that could be happening across the whole system, like a wide, like a wicked problem that affects everyone, like a cyber attack, or could be a climate change impact or an earthquake or something. But this idea that you need governance at that multi-agency level. Across the x-axis, I've got the system scale. So what do we do in the organisation to deal with these things, and what would we do across all infrastructure? So this is basically who will manage it. So in the first box, when we think about the organisation managing its operational continuity, this is where we would put in our reliability processes. We'd put in business continuity, probably emergency management, the things that that organisation can do on its own for its own customers. When we think about infrastructure at that operational level, we need to think about the absorption and recovery. So how much of the hazard can we absorb at that organisation level so that it doesn't contaminate or spread to other organisations? And how quickly can we recover? Because we need the timeliness of recovery. So this is very much about bouncing back at that operational level. When we think about the more strategic level, so this is about the senior management team, the sort of decision makers in organisations working out about their survival, managing those risks. And then at the resilience level, we want to think about how this layer can actually recommend adaptation options. And it might be an adaptation option that's not necessarily in their organisation. There could be an adaptation, for example, in their supply chain or in somewhere else in the community that can actually mean that they can actually be more viable and survive. So it means thinking beyond what they do now. And then in the multi-agency factor, I think this is where we need the systemic risk to be managed across multi-agencies. And this is perhaps where disaster risk reduction sits, because it's a multi-agency challenge. And then if we're worrying about resilience, then the systemic resilience governance ought to be there, again, for infrastructure. So this is the multi-organisational system. So this is where I think this is the landscape that's sort of coming out. I'll probably stop there. I've got another slide on digital infrastructure, but probably I've gone over time already. So if that's okay. Go for the next slide. Okay. You're glutton for punishment. Okay. So we're in a digital age, so you'll have heard of Industry 4.0, 5.0. We've been adopting technologies, particularly with cyber physical systems. We've been using AI. We're using a lot of the automation technologies that we can have, the machine learning and other algorithms. And essentially, we're doing that to be more efficient. But actually, we've got much more opportunities, including ones that give us outcomes for resilience. So we can learn from our systems, we can monitor our systems, we can provide alerts. By having this digital layer, we can actually get information that's useful to the operators, but also to the people that are using either the buildings or the structures that could actually be damaged by some external event. So some examples of the sort of digital technologies, we're seeing these very widely, building information models, smart city models, and so on. But there comes a warning with the whole digital infrastructure as well, because obviously we're creating all these server farms, which are also using loads of energy, which are often not clean energy, and therefore they're contributing to climate change. So you've got a vicious cycle going on here, whereas we're not really solving the problem. We might be solving the digital information access problem, because we've now got information we can use usefully, but actually we might still be contributing to climate change. So we need to try and solve that as a whole system. Okay, shall I just do this? Do you want to see this example? Okay. I love this example. Okay, so this is the Thames. This is the Thames barrier. So basically, this is one of about 9 other barriers that exist in the River Thames. These things you can sail a ship through these. I mean, they're quite wide apart. But if there's either a surge coming in or the sea level's high, the tide's high, what they can do is they can push barriers out from each of these, and then it creates like a wall. That means that the floodwaters don't go over. So hands up, how many times do you think this has operated in the 40 years that it's been built? 40 times, not bad. Any more? Higher, lower? 10. You see, this is what I need, a skeptic. Any more? Higher, lower? Lauren knows the answer because we had it this morning. Okay, over 200. Okay, now this system has saved the real estate in London, 175 square kilometres of real estate, our London Underground, our financial district, which if we were to allow these floodwaters into, would devastate our industry, our economy, 200 times. I mean, people like this because it's a nice solution. People like to show the picture of the Thames barrier, but actually the impact of this, it's been like a silent success. And this is, I think, what the challenge in resilience. How do we shout about these successes? How do we tell the stories of its work despite these high flood levels, these high sea levels? It's worked. I'll leave you with that thought. We need to tell more about the good stuff. Yeah. Oh, thank you. Thank you. Thank you. Oh, maybe. Yes, please.
Thinking about your little framework that you did a couple of slides.
Yeah.
The multi-agency. Who does that at the multi-governance level?
We're not doing as much as we could do. So we've got we had 2 organisations, the National Infrastructure Commission and the Infrastructure Projects Authority. So the National Infrastructure Commission was like a thought leadership centre. The Infrastructure Projects Authority held the pipeline of all the £1 billion or greater projects. Now they've been merged into one called NISTA, and so they ought to now be leading on that. And the idea is that we're sort of protecting them because they're helping us with the long-term decisions. So it shouldn't be so vulnerable to the sort of political change. But every government that comes along, new manifesto, is going to be upsetting the programme of works no matter what. But I don't think they're doing as much on resilience as I'm recommending. There's a lot more they could be doing. I think people have grappled because it's been a difficult thing to define and what it is. And now that we have these principles, what I didn't mention was that the UNDRR work has led to these principles being adopted in several countries now. So already we've got examples of where they're working. So you can do an assessment of your resilience. It can give you action plans of where to improve to be more resilient. And of course, you create your assessment based on your own hazard experience and your own expectations of what future hazards might be like. So you can assess whether it's worthwhile making that investment, even though you might find actually you're not going to be very resilient for this particular point. It might not be so much of a risk for you, so you can accept that risk. So it gives you a mechanism, and I think we've suffered because we haven't had that mechanism before. But now we've got it, and we don't need to be retrospective. We can be proactive and looking forward. Yeah. But more needs to be done. There are some countries. Singapore's doing a good job. Yeah. Yeah. You don't want to hear that, do you?
Anyone else?
And I really would like any thoughts on this framework, because how we manage risk and resilience is like really challenging. How do we manage the integration of it? Because as I said, if risk is about the probability of something, resilience is definitely about acting on something's happened, So you need to either recover it or you need to stop it getting worse. It's about action. Yeah. Yeah.
How do you try and capture those things?
Yeah, I think this is with if you're getting the data, and actually if you're doing that continual pacing to what might be happening in the future, so you're not doing the maintenance, so your asset's always degrading, because depending on the load, on the demand on that asset, it will be getting worse over time. So if you have an asset that lasts 60 years, say a road or something, you have to do maintenance at certain times to just repair the top layer, but probably not the subsurface layers. So that there's an element of maintenance that has to happen. If you're not doing that, then it's going to be more vulnerable to the hazards. So you can see it sort of dropping. Then if you have the data, you can say, well, actually, it's dropped to a level I've really got to repair it now. And so it's like condition based. So if you get in the data and you understand what's used in the system, then I think because it'll be much more dynamic. It will appreciate what the context is, rather than being so bound by what's gone in the past. You'll actually be seeing what's going on now and seeing what the pathways might be. You do. And I mean, one of the processes that we've got in the principles is about having open data standards. That doesn't mean I want to share open data. I don't want to make data open across all companies, but I want them to have a standard so that they can actually share their data, so that if we need to in an emergency, then we can use that standard. So if we can, there are some very simple things we can do to actually increase resilience, but it's actually getting those first steps done and showing that it's worked and actually minimized the impact from different hazards or threats. Yeah.
Anyone else? Any questions from the online audience?
Oh,
Here we are. This question from Jordan. Question to the New Zealand crowd. Australia has introduced the security of critical infrastructure similar to the EU framework. Has New Zealand done something similar?
You've definitely got a resilience adaptation framework and strategy, but I don't know. And you've definitely got something on cyber security, haven't you?
Yep.
I think you have got something. I've definitely seen some documents, but I don't know whether that's just the ambition to do something or if it's actually being implemented yet. I haven't seen. You think it's not yet implemented? Oh, well, no. Should we go there?
Someone from Jordan from Australia asking the question. Yep.
Yeah.
I think in New Zealand, I'm not sure about that particular framework,
Yeah.
but we definitely have
Something.
resilience systems.
Yeah. Yeah.
Through the lifelines groups.
Yeah, definitely. Yeah. And I'm talking to those as well. So hopefully I'll get some feedback and then we can try and what can be done to just raise the profile of it, do some more shouting about things that are working, and actually show that it's worthwhile making these investments, because obviously it's a taxpayer burden whenever these things do go wrong, because it means you have to foot the bill, because the organisations can't afford them, because these are almost like things that they say go beyond what they should be able to do. But actually with some prevention and some good design, actually they could minimise this a huge amount and reduce the taxpayer burden. So there's a real incentive, I think, for people to be wanting resilience.
Has there been retrospective cost benefit on Thames Barrier?
Yeah, that's a really good one. I haven't seen an evaluation yet, but I will go and have a look. I mean, I'll look it up for you. I mean, I would say it's probably about 10 times worth its, for benefits cost ratio, 10 times I would guess. But, who knows? Yeah.
Dare I say, prevented from ship collision, or is there some mechanism that prevents ships from being?
It's a good point. Yeah. Well, I mean, I've been on going up and down through it. So, but I mean, I don't know if they have a particular protection system. I think I'm trying to, they have these additional bollards underneath. So perhaps the ships they collide into that. They don't damage the barrier, but I wouldn't be certain.
Usually in retrospect, they're found to be woefully inadequate.
Well, this is the other thing, they're 40 years old, this system. How long? I bet it was probably a 60-year life. Ship size. Yeah. And if you think about the microplastics and the other things that are now in the waters, God knows what that's doing to erode, the materials they use to construct these with. So, I mean, it could be that's the next biggest issue for London, is that the barriers won't work because of the new context. But I mean, they called this smart engineering at the time, and this is 40 years old, literally 40 years old. They didn't mention the word resilience, not once. All about smart engineering. And they collect information all the time. They're getting meteorological, they're getting wave, they're getting sea level, everything. They're getting all that information, and it's a digital twin, just like an air traffic control system might be, to know where the planes are to avoid the crashes, Yeah. So it was, I mean, digital twin, I know we think of that as a very modern term, but actually there are some systems, I think, that have been genuinely like that, like dynamic data collection and supporting that operational decision making. But of course, with AI, we have so much more potential, because the more data we have, the more we can put it into these, data farms or server farms, and we can actually do more analysis and actually be maybe predicting where the next thing will go wrong, because we can run the scenarios. I mean, we've done a lot of work digitally, and these algorithms are not, I mean, they're available. We can run these algorithms, understand the uncertainties on them, and then get some predictions. So that's, it's not the technology that's holding us back. It's the operational environments, because the organisations haven't quite got to the level of capabilities of getting good data, cleaning their data, being able to share it easily. And this is why open data standards becomes a sort of a possibility.
Didn't see any reference in your presentation to global pandemics. I sort of wonder, did I not see it? Has it not been considered, or is it there well hidden?
No, so I didn't mention it explicitly, probably somewhere. It might be in one of the slides. It's just another threat. It's like a health threat. Yeah, it is. And it does change the use of infrastructure. If anything, it made infrastructure better, because the load on infrastructure, so transport systems weren't being used, air traffic, we weren't having any flights. So actually it meant that the load on our transport networks was much lower. I mean, it meant that the distributed energy needed to be more effective because people needed the power and heating and lighting in their homes rather than in the office buildings. But then even then there were people implementing strategies to turn off lights and power heating to buildings so they could avoid the cost.
Thinking of things like food supply,
Yeah,
supply chain interruptions, particularly in a place like New Zealand,
yeah.
so isolated, it was a very significant factor.
Yeah, yeah. Do you know what? Food hasn't come into infrastructure in that way, yet you'd have thought it was an essential service. They just haven't quite brought that in. The people I was talking to, I think at New Zealand Payments, you have like your FPOS people, NZ PayNet or something. They were talking about how, and I think they were using an example from another country, how you still have to retain cash in the system for the banking system to be resilient. So if the telecoms or the power goes, you can't make your electronic payments, you still would have cash at home. And the three shops, if you like, that have to stay open are the grocery shops, and they have to be able to take cash, the pharmacies, and the refueling stations, and they all have to be able to take cash. So they're saying keep something like, I don't know, $60 in cash always at home so that you can always go and get these essential services. So they're seeing that because the banking system is definitely an infrastructure, and they're seeing that as a like an alternative pathway to get the services you need, because at the end of the day, it's about how do you get the services. So if their telecoms or their power systems have failed, you can still get the service you need by paying for it, but actually it's through cash now, not through their system. I'm not saying it's a great solution. And I mean, I look at the grocery shops and I go, I don't think they know how to take cash anymore because none of them have taken it for about 3 years. but it's something to think about as an old, could work. Yeah. Well, maybe I'll just have loads of tins of beans or something at home, and then, I mean, it's honestly, sometimes the resilience, it can be down to the household level, and just having those stores, bottled water, litres and litres of it, just to keep you going, because hopefully they recover these essential services within, well, hopefully a day, but at worst, a week. So actually you've got a chance of like surviving. You stay put and you survive. But I'm sure hazard people will tell you, Lauren maybe knows much more about behaviour than I do, about how to behave in these conditions as well, because that all comes into it, and how you can get help from your local communities, and how you need to ask for help, because all this is part of being resilient as well. Yeah.
No, go ahead.
So one of the challenges that we have with resilience from a social perspective is that it's something that we build before the event, and it's only really demonstrated during an event. Yeah. So we've had to try to find all sorts of proxies to make the case that the work we're doing is actually improving resilience in our individuals and communities. How well can you determine if the improvements you're making to infrastructure is actually building resilience in the absence of an event that tests it?
Okay, so you can use your models. So your like the reasons why you're making those interventions in the first place. So you'll have justified why that was a good idea. So you can model the system without your intervention, and then with your intervention, and you can show that the level of resilience has gone up by, I don't know, 5%, 10%, whatever, however you're measuring it. So, and then you can show how the context is now changing to be more like your models. So therefore you needed to have that extra 5 or 10% more resilience. But then this is all about collecting data and about being smart about how you use the data to justify it. In the handbook that we created with the United Nations in 2023, we had several examples of people where they had made business cases for resilience, where often where something had gone wrong, but they, instead of rebuilding back the way it was before, they were building back in a way that would be resilient to the future climate change or other risks that they would have. And so they were already almost ready with their solutions, knowing that something would fail, but actually had the solution there to go ahead with. But it's all about learning and experimenting and, you know, knowing what will work. Yeah. Are we done?
Fine.
Yeah, go for it. Yeah.
Talked about a lot about resilience and getting resilience in terms of the operations and in the work you've done with the United Nations.
Mhm.
Has there been any thinking about the actual designing for resilience,
Mhm.
including thinking into the design process?
Yeah, so one of the 6 principles is basically design for resilience, because it's about being proactive. And in there, we probably have the most processes, because actually what we want to do is build resilience into the solutions, so that it's so they're adaptive, so that we can, if we have different challenges in the context, we can cope with them. They can be transferred. So if your demand changes, you can change your system to meet the demand better. And so you can be more resilient. Yeah. So it's definitely, there's one of these 6 principles, design for resilience. Yeah. Yeah.
Yeah, thank you.
Thank you. Thank you very much.
Yeah, thanks.
And do get in touch with any great ideas. You can find me online, just email me, and recommendations always received, well received.
Yeah, very insightful and challenging talk for us to think about.
Yes,
So
please.
thank you
Yeah.
very much.
That's your homework, right?
Okay, Miss.
Thank you. Thank you very much.